Hi, so I'd like to start a new topic. I'd like the new topic to be elements, mixtures, compounds. Um, First lesson, I'm going to get into the periodic table. So, logically, we've been talking about particles making up everything in the universe. So now, in order to make progress as to what those particles are, then we have to delve into the idea of what atoms are, what elements are. So, if I just pose a question, those particles we've been talking about, what makes them up? What are they made of? Well, I've already mentioned there are three different types: atoms, ions, and molecules. But all of those atoms, ions, and molecules, they themselves will be made up of protons, neutrons, and electrons. Now, I know this might be too much to take in, but we've got to make a start. So there's lots of terminology here. You've slowly just got to get your mind around it. So everything is made of particles. The particles themselves are made of protons, neutrons, electrons. That simplifies it. We'll get into what molecules are and atoms are exactly and what ions are later. And I'm going to mention atoms in this video. Well, what do atoms themselves look like? So we're talking about protons, neutrons, electrons make up atoms. And the atoms is the starting point for understanding molecules and ions and particles overall. But what do atoms look like? Now, if you go and get diagrams out of books, they're weird and wonderful diagrams. The world is lovely, diverse world made of different ideas and different presentations of diagrams of different things. So that should not faze us. But there are two that I want you to focus on to get your understanding right. One is a three-dimensional diagram. Here we go. Three-dimensional diagram. I want you to picture atoms as being made up of a central nucleus. That is that centre, highly dense nucleus, which has got in it protons and neutrons. So protons and neutrons make up the centre, and that's the nucleus. That's the name given to the centre. And whizzing around the outside in what we call orbits, or what some books may call shells and subshells, whizzing around the outside around the nucleus are electrons. So electrons are in orbits around a central highly dense mass called a nucleus. Now, most of the time we can't draw three-dimensional diagrams. I mean, I myself, rubbish at art, find it hard to draw three-dimensional diagrams. I do and can draw the ones that I need for chemistry. But my wider drawing skills are not good, but poor drawing skills should not put you off drawing the diagrams that we want you to in chemistry. As I say, my own skills with drawing are poor. So most of the time in chemistry, they ask you for two-dimensional diagrams. There. That kind of diagram. Now that kind of diagram is something we will be drawing a lot of. Electrons whizzing around the nucleus, which is in the centre. A lot of the time we're going to be saying how many neutrons, how many protons, how many electrons in whichever energy level we're talking about. But those diagrams are common, and I hope you agree with me that you should be able to draw those kind of diagrams easily. So what's an element? Well, I want you to learn this definition of an element. I'm going to say to you that elements are made of atoms. And a particular element is made of atoms that all have the same number of protons. So it's the number of protons that's the key. The number of protons will identify for you a particular element. Elements are made up of atoms that all have the same number of protons. Learn that. Learn that. For GCSE, they're going to want some definitions, and that's one of the definitions I want you to learn. Now, there are other ideas that are floating around within books and the internet, etc., which I don't want you to write down. I mean, they're not wrong. They're just things I don't like. I don't think they give you the right thinking that you should have for chemistry, but they're valid, they're correct in their own way. So what other things might you come across? Well, you may come across true, but not definitions, include the following. The elements are listed on the periodic table. Now, if you're asked to define an element, I don't want you writing that. I want you writing that, not this. It is true that elements are listed on a periodic table, but it's not robust enough for a definition. Equally, I would argue this next definition, which is much more common in the chemistry books and internet, which again is true, but I don't like it. It's not robust enough. Elements cannot be broken down into anything simpler. Now, it is true, if you've got an element, it can't be broken down into anything simpler. But it's not robust enough for it to be a good definition that I'm happy with you using, or GCSE is happy with you using. So learn the top one. The elements are made up of atoms that all have the same number of protons. These, just take them as statements that are okay, but not definitions. Right, so the main part of the lesson, periodic table. Now, the various things about the periodic table that I want you to learn, and for this you're going to need a pencil. So first, pause it here if you haven't got a periodic table. Go and get a periodic table, get a pencil, and then start playing the video again. Right, so with your pencil, I want to mark first, I want to mark all the elements that are not metals. Well, what elements have you come across that you'll be able to identify as not metals? Well, you might not be able to see that very clearly, but on your periodic table, boron is not a metal. Carbon's not a metal. Nitrogen, oxygen, fluorine, helium, neon, argon, krypton, xenon, radon, astatine, tellurium, arsenic, silicon. Have I been through those? Phosphorus, sulfur, chlorine, argon, bromine, selenium, iodine, and hydrogen. All of those are not metals, and you've got to know which elements are metals and non-metals. The main category, division within elements is metals and non-metals. I want you to be able to use your periodic table. You will always have a periodic table in the GCSE exam. I want you to use it to identify which is a metal and which is a non-metal. It's fundamental to our understanding of bonding later that you can identify which is which. So how can you? Well, this periodic table has a red staircase line, which if you start at boron, go diagonally downwards, and anything to the right and above is not a metal, and hydrogen. Hydrogen over there. It's not always over there, sometimes it's in the middle here, and occasionally they put it here next to the helium. But you've got to know all of those are non-metals. Can you, with your pencils, can you shade in all the non-metals and label them non-metals, shade them lightly in pencil. Having labelled all of the non-metals and understand that what we mean by a non-metal is it does not have the behaviour of a metal. Metals behave like metals, non-metals behave not like metals. That's kind of like obvious, but I thought it was so important it's worth saying. So then, where are all the metals? Well, look. Everything else here, all these, all these, all those, all these, all of those, all of the rest are all metals. So with your pen, label it. The shaded ones are non-metals, but everything else is a metal. And that is the main classification that I want you to know about. However, there's a few other things I'm going to mention now, which I also, while we've got the periodic table, I want us to label. I want us to take this periodic table and know that there are families. There are families of elements that behave similarly. And the families of elements, we don't call them families, we call them groups. And within a group, the behaviour of elements is very similar. So, the first group, this group down here, starts with lithium. Hydrogen is not a group 1 element. Hydrogen, most periodic tables have it separate. So starts with lithium. Lithium, sodium, potassium, rubidium, cesium, francium. All of those is one family and they all have very similar behaviour. They're called group 1. I want you to label all of those, and the label is normally written at the top here where my finger is. Label that group 1. Well, the next column, so the first column is group 1, the next column is group 2. Where my finger is, label that group 2. All of these elements are called transition elements. So you can write transition elements here if you want, or transition metals. You're probably better off writing transition metals, because they're all metals, and that's what I want you to know. When we get to boron, aluminium, gallium, indium, thallium, all of those, that column is known as group 3. So write the number 3 where my finger is. That is group 3. Carrying on then, all of those are group 4. All of those are group 5. All of those are group 6. All of those are group 7. And all of the last lots, that's helium, neon, argon, krypton, xenon, radon, are group 8 or group 0. Now most periodic tables label them as 0, group 0. Some periodic tables call them group 8. Some periodic tables name them. They're the noble gases, they are the inert gases. So either noble gases, inert gases, group 8, group 0, they all mean the same thing. They all mean that set of elements there that are in that column. So the vertical columns are groups numbered from 1 to 7, and the last one number it 0, so that you know those are the groups. Now we're going to link groups with however many electrons that they have later, and you need to know what group number they're in order for us to do that later. Okay, so next I want to talk about not the vertical columns, but I want to talk about the horizontal rows. Now the horizontal rows in chemistry are called periods. So periods, the first period is very, very short. The first period is helium and hydrogen. sorry, I was pointing. Hydrogen there, helium there. Hydrogen and helium, those two elements make up the first period. And we will link this with the number of electrons later. So you need to know what period these elements are. So period 1, can you label where my finger is here, that horizontal row is period 1. Once you've done that, next horizontal row is period 2. They're the elements lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon. Those 8 elements are period 2. The next 8 elements are period 3. The next elements here are 18 of them. They're period 4. Those are period 5. Those are period 6. And those are period 7. So I want you to number them 1, 2, 3, 4, 5, 6, 7. And I want you to write on your periodic table that those are the periods. Now some periodic tables won't have the lanthanides and actinides listed, but these are the lanthanides and actinides. And the way the periodic table works is, if you could lift those up, there are 28 of them, 2 lots of 14, 28 of them, we can lift them up and put them in here. It would make the periodic table very, very long. And that's why we don't do that. We simply write them at the bottom so that we can fit the whole periodic table onto an A4 sheet. You won't be asked any questions on this. Indeed, there's only one of these that I think is important for us. It is uranium. A lot of the nuclear industry is based around uranium. But the rest of them, you're not really going to come across at GCSE in any way, shape or form. Even uranium you're not going to come across at GCSE. So, out of these, how many are there? Well, I think at the moment we're up to about 118 elements. So out of 118 elements, I mean this one is up to 114. People are trying to find new elements as we speak. But all the really common elements, there are only 92 of those. Those are discovered. Almost everything is made from those 92 basic elements. And out of those 92 basic elements, I'm not even going to ask you to learn those. I'm going to ask you to learn the most common 25 or so. Like hydrogen, capital H, oxygen, capital O, sulfur, capital S, sodium, capital N, small a, magnesium, capital M, small g, chlorine, capital C, small l. Can you see there's a pattern? When we've got one letter, we just use capital. When we need 2 letters to differentiate them, like chromium, separate to calcium, calcium Ca, chromium Cr. So where we need 2 letters, the first is a capital and the second is a small letter. And you must get used to writing capitals when you need capitals, and you must get used to writing small letters when you need small letters. If you get them mixed up, that is, put a small letter instead of a capital, you're going to lose marks. What if you put like a capital where a small letter should be, you're going to lose marks. Equally the other way around. If you use a small letter where a capital should be, you're going to lose marks. So it must be that when we're writing symbols, and we will be, this unit will be writing symbols and names of chemicals using symbols, which we call formulae, that is going to be crucial. That you use the periodic table, you get the symbols that represent that element, that one's osmium, capital O, small s. And you must, whenever you talk about osmium, write capital O, small s. And the capital's got to look like a capital, and the S has to look like a small letter. And if they don't, if it's not clear, you lose marks. So the periodic table of elements is the materials from which our universe is made. They're our starting point. It's a bit like, how many letters of the alphabet do we have? Well, we have 26 letters of the alphabet. From those 26 letters, how many words can we make? We can make millions of words from that basic 26 sets of letters. Well, chemistry, we've got 92 common elements. 92 common elements that make up, at the moment, about 9 million different chemicals on our world, with new ones being found every day. So the story of chemistry has to get down to the basics of what everything's made of. And if I recap, things are made of atoms. Atoms themselves are made of protons, neutrons, electrons. The number of protons identifies for you what material that will be. 6 protons will always be carbon. 12 protons will always be magnesium. 17 protons will always be chlorine. The number of protons will identify for you what element you've got. And the elements are the materials that exist on our Earth. 92 of them. They exist, they are common. And through using those 92 elements, by joining them together, we're going to make compounds. And the compounds are varied, and there are millions of those made from those basic 92 elements that make up the materials that are present in our world. I'm trying to get the next slide, and my computer is not doing so. There we are. So I've asked you to shade and label those things. I've been through that with you. And then I've said that what identifies the element is the number of protons that are inside the nucleus of the atoms that make it up. The number of neutrons won't affect the element, and the number of electrons will simply decide what charge it will have. If it's neutral, it will be an atom. If it's charged, it will be an ion. From the proton number, we can identify what element we have. So I'm going to draw this to an end, but if I turn that off and talk to you, if I could leave you with one idea, it is this. It is the number of protons. If from a periodic table you can find an element and work out the number of protons, which is, by the way, the smaller number within that little box, the smaller number will tell you how many protons you've got. That number of protons fundamentally tells you what the element is. So 12 protons, it will be magnesium. 11 protons, one less, would make it sodium, which is entirely different. Sodium is entirely different to magnesium. One extra proton, 13 protons, will make it aluminium, which again is entirely different. But 12 protons, regardless of how many neutrons or electrons it's got, will always be something to do with magnesium. So the number of protons identifies the element. The element can be identified from the periodic table if you know the number of protons. And you go a long way from knowing that it is the number of protons that is really important and will identify for you that element. Right, I think next time I'm going to deal with elements which I've dealt with and talked about today, but next time they coming together to make compounds. Like elements come together to make compounds, and we'll do that next time. Take care.